Alrighty, 12:30. It's nice. I have a class before this one, so I'm like always here on time. Getting to the first one is rough sometimes. I've never been a morning person. Like, so one of the reasons I got into computers. Generally, we're not morning people. So, I don't know. I'm unmuted, right? Okay, good. I'm not on mute. I gotta open it on this one. So what got you folks into? So not everyone's a data science major, if I remember right. I think there's a math major, maybe someone who did physics here. But most of you folks, I think, are data science majors. So you must like computers, I'm assuming? No? Just curious, like what got you into it?
To be honest, it was math. Math was one of my strong suits. I didn't want to become a math major. And then data science uses a lot of that. And so it was like, data science is also IT, lots of opportunities. And I was like, sounds like I can do it.
Okay. Yeah, definitely. There's a lot of math for sure. And like the difference in a data science degree versus like an analytics or data analytics degree is we look more at the science and more at the math. Like how does stuff work rather than let's do things with data, which is interesting. So some people look for like if all you want to do is analyze the data, you don't really care about the math. You do more of an analytics degree. Like the business school offers something like that, which is a little weird. The colleges don't really compete, but we sort of compete. I don't know how all that works here at the university. Smiley said less school and easier than pre-med. Okay. At one point I thought I wanted to be a doctor because like I don't know, a lot of kids want to be doctors, and then it turns out I have this phobia, not even a phobia, I have a vasovagal reflex, and if I get shots or blood draws or even just like seeing people's blood, I'll usually pass out, which is really fun as a diabetic. So I've gotten better at that, thankfully. But when they take my blood every 3, 4, 5 months, I usually pass out, which is awful experience. But so I was really sad when that Theranos lab company went out of business for being frauds, because that would have been a game changer for me. Because I can do like the finger pricks, like you can lose a drop of blood, but put a needle in my arm and I'm out. Just like when I got my tattoos, I passed out twice. It's like, no, it's okay, it happens. You can keep going. They're like, really? Like, yeah, it happens. It's okay. And they're like, all right, sure. So my wife was like, why did you go get another one? I wanted another tattoo. Like, isn't that awful to pass out? Yeah, but you get it done and over with. Yeah, no, data science is interesting for sure. Really interesting field. Working with data, understanding data, drawing meaning from data. I wish I could say we're going to get into that, but we're not. Like, this is our first semester programming, so we need to figure out how to write code first before we can actually go and do interesting things with data. So our last project will be ever so slightly interesting, but not anywhere that anyone looking at it will be like, yeah, that's a data science project, because we just can't. So next semester we'll get a little bit closer. If you're continuing on in the program and take 2001, you're stuck with me. I'm sorry, unless they get rid of me, which is fine if they want to. But I've been doing the Python courses for the data science program since they started the program in 2016. But happy to change things up. And things have changed. So when you fill out the end of semester surveys, my poor chair gets to read all of those. I don't know if he actually does or not, but he's part of my annual review process. I send them all to him. But I take them seriously, so I'll look at what folks say and try and adapt things as possible here. There's certain requirements we can't avoid, but try and keep things working well for you folks. So should be a lot of fun. We'll get into it. We're getting into loops now, which is one of my favorite things in code because it lets you be lazy in that you don't have to do the same thing twice, right? I think I mentioned the general rule of thumb is if you have the same code in your program twice, you should feel bad about yourself. It's a pretty good rule of thumb. So loops are one way that we can avoid doing that, so we don't have to feel bad about ourselves, which is just a joke. I just apologize. It's trying to be lighthearted because it's really hard to sit and do heavy stuff all the time. So we'll look at that. And then come Wednesday, the first thing we're going to do is start with Project Zero. So I'll go over how I would solve it for Project Zero. So I do need it in on time. I can't take it late. Just your last reminder. If you haven't started yet, there's still time, promise. But please don't wait until Wednesday morning or Tuesday night and be like, hey, Eric, I've got a bunch of questions and I don't know what I'm doing. right? That's why we have 2 weeks for all of them, so you can ask me the questions early, and then I don't feel bad about not being able to help you Tuesday night. Because, I'll usually I can meet with people after my kids go to bed, but I can't spend all night doing that. And then Wednesday morning I have a class before this one. So like if you're texting me in the morning at 9, be like, hey, I don't know what's happening. It's really hard to help at that point. So please just plan ahead, and we'll go from there. So, yep. All right. So we're going to talk about loops today. Let me fire up PyCharm. And loops are fantastic here. So this is really week 5. Wow. This is a third of the way through then, by the time we're done with this week of the fall semester. And it's still September. That's crazy. That's just crazy. Okay, so we start a new project here. So we'll try and keep these organized. It'll be week 5 loops. Now there's a couple loops in Python. 2 main loops we're going to look at. The first loop is pretty easy because it's similar to what we've looked at with branching in that we're going to use that Boolean condition. So if something's true, something will happen, just like our if statement here. So I can say, hey, I want a number, we'll start it at 10, and then I'm going to say while. So instead of if, it's a while. So we'll say while number is greater than 0 and a colon. So it looks a whole lot like an if here, but it's while. What happens is the loop will run. So just like our if it's true, this block of code will run. So anything that's indented underneath my colon here is going to run. So we'll print number, and then I'll take number -1. Not very interesting. But we'll just print the number, we'll take number -1. Now, if this were an if, it would just continue on to line 6 or 7 or 8 or, keep going here. All done. That sort of thing. But what happens with the while loop is once this loop body here is done, once all of the code that's been indented here is done, we come back to the loop and it checks, hey, am I true? If it's true, it runs again. So it's like an if that will keep repeating. While this is true, it will keep on running. So this is known as a pre-test loop. So it's possible this loop never runs. If this is not true, your loop doesn't run. Now, I know it's going to run because I set number to 10, but like if I ask the user, hey, enter a number, and they give me -7 because they're a weird math person, and they're like, haha, you asked for a number, I'll give you a negative number and screw with you. My loop doesn't run because -7 is not greater than 0. Most people, when you ask for a number, will give you a positive number, right? But users will do the weirdest things with our programs, and that's okay. We'll look at some ways we can deal with that later. But so it'll probably run, especially if I give it a value. But if we ask the user to enter a value, it might run. We don't know for sure. So it's a pre-test. So it will check if it's true, the loop runs. When it's done running, so when the loop body is done, go back to the top and check again. Right? If it's true, if the condition is true, it runs. We get to the bottom. If it's true, run again. If it's true, run again. If it's true, run again. So something that happens occasionally is you forget to change this value here. So if you forgot to change number here and you just print the number and I run this, I now have an infinite loop. It's just going to print 10 forever because it's still true. It's still true. And Python was happy to just run this forever because it's doing what we told it to do. Sure. So you need to be careful that you are changing the condition or changing the thing you're comparing so that it at least has a chance to end here, right? So in this case, I know it will count down and it will work. So we'll get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, we should say blast off. There we go. We should say blast off. That's more fun. Okay. So we will blast off after. And we know it'll finish. Awesome. So we can do something like that. That's a basic while loop. Okay. Now we can do other fun things here. We can have, say, like a magic number. We'll say is 42, and then I'm going to ask the user to guess a number. So we'll have the users, or we'll just say guess. Right? It's an int of an input. Right? If we don't convert to an integer, I can't say if it equals or not equals. Right? I can't compare integers and strings. Right? So we always do the conversion here. We'll say enter a number or guess a number. Right? Guess a number 1 to 100. I'll have guess, and now I'm going to say while guess does not equal the magic number. Let's do something. And, we can say wrong, try again, or I don't know, wrong, and then we'll ask them to guess a number again. So as long as I'm changing the value here, right, there's a chance the loop will end. Now this is based on the user entering something. So if they never enter 42, it'll technically never end. But at least there's a chance that it's going to end here because I'm going to change the value of what I'm comparing. And then when we're done, we can print, guessed it, yay! Right, so we can play our little game here, and we can guess a number 1 to 100. What should we guess? 56. Wrong. Guess a number 1 to 100. 24. Wrong. Guess again. 42. You guessed it! Yay! How'd you know? Okay, we can test for that. We can see if she floats.
Yeah.
Right? Okay. So again, this is not the most interesting guessing game at the moment here, but and usually when you're playing a guessing game, it's useful if you tell someone if they're too high or too low. Right? So we can do that, right? We can say, okay, hey, how about if guess is less than the magic number, we'll print too low. If you're not less than the magic number, and you're not the magic number, you must be, you're not less than, you're not equal to, you must be greater than, yeah, too high. So else we'll print too high. Now, there's nothing wrong with adding in the else if and saying this is greater than. It's just redundant at that point, and we don't need to. And remember, programmers are lazy, right? We don't want to do more work than we need to. So I know I can't be inside the loop if my guess equals, because that's what the loop says. If you're not equal, please run. And I know you're not less than because I'm checking over here. So it's just a shortcut. Nothing wrong with including that here. It's just less typing for me. And ever so slightly faster because Python won't ask the computer to evaluate that. Now, computers are really quick at comparing integers. Like, are you greater than or less than? You can do it really fast, right? So we didn't really save a whole lot. We can't be like, hey, look, we've optimized our program. It's so much faster. No, we're not going to notice the difference. If you did this like a bazillion times, yes, you might notice the difference. We're not doing anything a bazillion times yet, so we don't care. Okay, so we'll tell them too high or too low and guess a number again. Should we try it? Right, because anytime we write some code, we want to make sure it works. So let's try something. Should we do too high or too low?
99.
99. Too high. That part works. How about a number that's too low? What? 33? That's too low. What should we guess next? 42? You guessed it. How'd you know? You got it right. Amazing. All right, so it seems to be working. Now, wouldn't it be cool if we could count how many guesses that took them? Let's do that, right? So this is a guess count. Starts at 1, right? Because they guessed 1. And then every time they have to guess again, we'll take guess count plus 1. And so you guessed it in guess count, right? Do this as look at that, even added the F for me. I love it. PyCharm is so nice. Right, a little formatted strings. We talked about those, right? I'm not seeing a lot of head shaking. Do we do these? Okay, thank you. I'm sorry. Yeah. So we guessed it in this many guesses, right? And we'll keep counting. All right, let's try it again. All right, guess a number. 1. Too low. 2. Too low. 4. It's too low. 5. Too low. 42. We guessed it. 5 guesses. Is that right? 1, 2, 4, 5, 42. 5 guesses. It's counting correctly. It's looking good so far. Now, I know 42 is a great number, right? We love the number 42. If you're not familiar with it, go read the book Hitchhiker's Guide to the Galaxy. It's not even like pop culture anymore, right? This is just, is that like a niche classic book now? I don't know how many people actually like the book, but nerds usually like the book. Sci-fi? Okay. Anyway, it'd be better if it could be a random number, right? Because then, like, we don't know what the number is that we're guessing, right? So to do that, right, we say random.randint, and we give it the too high and the too low, or the bottom and the top of the range here. So 1 and 100. And come on, there we go. We want to, no, come on. Yeah, usually it suggests it for me. I don't want to have to type it myself. Import this name. There we go. Import random. Okay, took 2 clicks instead of 1 click. There we go. If we import random, say, hey, Python, please let me use your random library. Right? Include the random library. Now we can get a random number 1 to 100, and I don't know what it is. So now we have to actually do some guessing here. Right? All right, so we guess a number 1 to 100? 50. Too high. 25. Too low. Oh, I did 24, sorry. 37. Too low. 42. Wow. That was really cool. That was really neat. I didn't do that on purpose. I don't have control over that. I feel like the universe is telling us something. Maybe we should add up the numeric values of the word guest and see if that adds up to 42, right? Gematria has got to be real. No, okay, sorry. It's a Monday, right? Okay, let's try it again. Just one more random value for fun. And I like you're splitting the difference every time. That is the correct way to do this search, right? It's a binary search. You're splitting it in half every time. 50 is too high. Uh-oh. 25 is too low. 42. All right, 42 is too high. 31. Too low. Somewhere in the middle. 36. Too high. 33. Too low. 34. Too low. 35. All right, 8 guesses. Not too bad. So now our game is like sort of interesting. Sort of. I can put this in front of my kids and they'll play for a good like 5 minutes. And then they'll get bored of it pretty quick. But so you can do this on a TI-83 calculator if you're bored in math class. But you can't use Python because TI has a stranglehold on math calculators. But there is a new calculator out there. I'm super excited. Python calculator. What is it here? No. Hang on. Oh, my goodness. ACT approved calculator. Python. What is it here? I can't remember the name of it here. It's a new calculator. It's really cool, and it's not TI. It was really NumWorks. NumWorks. That's what it is. They are challenging TI to the domination of the calculator market, which apparently is a big market. Like so many people use these calculators, and this will run Python on it. And I was super excited to see like a calculator that runs Python that you can use on the ACT. It's really cool. But long story, you can do Python on it instead of BASIC. So BASIC is the language you can use on TI-83s. And I have a fond memory of writing a guessing game in BASIC on my calculator instead of doing something I should have been doing in class. So why not, right? Anyway, now, number 1 to 100 is only so interesting, right? Wouldn't it be cool if we could guess a number bigger than 100? What if we asked the user, right? So how about we had a largest value is an int of an input. How high of a number do you want to guess to? And then our random number then will go to the largest value. And then instead of guessing a number, we will guess to the largest value. I think we can use the format string there. Guess a number to the largest value. Okay, we try that. So how high of a number should we guess to? 3. Okay. Guess a number 1 to 3. 2's too high. 1. We guessed it in 2 guesses. Amazing. Amazing. But now the game is even more flexible here. Now, what if we want to be able to run it, like play this again without having to keep on hitting the run button again? Can we do that? Right? What if we said all of this would happen? We'll say play again starts off as a y, and we can say while play again equals a y, colon. I can grab all of this code here and tap it in one. Now, as long as play again is y, we'll keep on running. I'm not changing play again, so what kind of loop do I have here now? An infinite loop. Yeah, if we never change this value, it's no good. Hey, Wally G, thanks for coming along. We're practicing some loops here. So make sure if you have a value, a variable, in your condition, you change it, right? Otherwise, you have infinite loops. So we should go ask them, do you want to play again? Input of, you want to play again, right? And then suggest a y or an n here for the user. They might not type y or n. They might give us something else, like sure. But that's fine. If they don't give us a y, we'll keep playing again. The other option, if you want to be slightly more flexible, you could say as long as it is not equal to no or n. So anything other than the letter n, we're going to assume means they want to play again, versus only the letter y means they want to play again. Totally up to you. It's just different ways of prompting your user and interacting with them. Right? Either way is perfectly fine here. And then we probably, again, want to lowercase it, right? Because sometimes users type in all uppercase and they shout at us on the internet, like boomers like to do on Facebook, right? I swear, like, the caps lock key is the worst thing we ever invented. We don't need to be typing in all uppercase. No one needs to be doing that. Right? At least make them work for it and hold the shift key down. If they really want to yell, like, you should make them put in the work for it. Like, then it's meaningful, right? Like, yeah, you know they were that angry to hold the shift key the entire time rather than just hit caps lock. Like, I would feel better about it. All right, so we just put the whole thing inside of a loop then and bring it in. So now we can run it. Right? How high of a number should we guess to? 3,000. Okay. Guess a number 1 to 3,000. We should get the middle, right? 1,500. It's too low. Like 2,350 or something. It's too low. 2,750. It's too low. Okay. 2,850. It's too low. 2,900. It's too low. 2,950. It's too high. Okay, so now we're within 50. All right, so 29.25. It's too high. 29.15. Too high. 29.10. Too high. 29.05. Too high. 29.03. Too high. 29.02. All right, we guessed it in 12 guesses. Yeah, Wally, we could just take the first letter if we wanted, right? Because these are strings or sequence types, right? We could take the first character here. I prefer to punish my users. I mean, sure, it would probably be nice to say, let's just take the first letter. If they typed in a whole word, if they typed in yes, we'll just take the first letter. Sure, that's probably pretty smart here. If we want to be, just take the first letter of whatever they entered, right? Because strings as a sequence type, so we can get at things by index, and then we can lowercase it. That's fun. We could do that. Right, and do you want to play again? Yes or no? We'll say no, and the loop stops or end. Right? So the loop then lets me do something over and over and over and over and over. So these are pretty handy loops for whether or not the user has said yes or no, or hey, if they haven't hit a particular number yet, or in our case, hey, we're going to count down. Sure, anything we want to throw in here is fine. Another really handy loop here is what I like to call a validation loop, and we can do that for our play again here because this is kind of fun. So instead of doing all of that here, we can validate that they have given us valid input. So we're going to ask them for some input, and then we're going to start a loop and say, if it's not valid, ask again. Right, so we can say while play again does not equal a y, or I'm sorry, it does not a y and play again does not equal an n. So if it's not a y and not an n, it's not valid, because those are the only two that are valid here. Right, and we'll prompt them again. So this is our validation loop, right? You can do these with numbers, you can do them with strings, you can, any sort of input you want. We're saying if it's not valid, run again, right? Like ask again. So the user can't get out of this loop until they give us something that's valid. So it makes it a little easier for me to check something later, right? If I know it's only one of these valid choices, like rock, paper, scissors, lizard, Spock. I can say, hey, if it's not rock, and it's not paper, and it's not scissors, and it's not lizard, and it's not Spock, well, dummy, you didn't enter one of the 5 choices. Try again, right? You can do these sort of loops to say, okay, right, if it's not in the list of valid choices, let's go for it. And then, which is nice because we have list notation as well. Like this is very, not too bad because there's only 2 choices here. We can also say, here's the like valid options is a list of y and n, right? And we could say while play again is not in the valid options. Remember we have that membership operator? This is even easier, right? You just have a single list here, and as long as it's not in the list of valid options, well, ask them again, right? Does the same idea here. So, and Python's really handy with strings, right? So with rock, paper, scissors, lizard, Spock, I could put all of them in a list and say, if it's not in the list, you didn't enter a valid choice. Or you could just make them lose. Right? It all just kind of depends what you want to do with your users. I like the if you pick a invalid choice, you just lose option. But again, when I grew up and played video games punished you for making mistakes. They didn't really hold your hand and be like, "Oh, hey, you went the wrong way. Go that direction." But that's just a preference, just a style preference. Either way is perfectly fine. It's probably better to be nicer to your users, just, at least for business applications, right? Does this make sense? So a validation loop, what we're checking for, okay? If we wanted to validate our largest value is within a certain range, we could do that too, right? If we don't want them to go more than 1,000,000 or something, or we don't want it to be less than some sort of value, we could do that, right? So what limits should we put on the largest value? Because like 3 was kind of silly, right? Maybe we should say that's too small. It's just an exercise. Hey, Y Paladin, thanks for joining along. Happy Blur's Day. So what should we do for the invalid range then? We'll say, well, the largest value is less than what value? What's too low? Anything less than 10? Is that fair? So if it's less than 10, or it is greater than what? What's too high? What just gets to be too silly for a guessing game? 1,000,000? Okay. And have you seen, did I show you, you can add underscores into your numbers for your digit groupings? This is amazing here because it's really hard to like see how many zeros are here. So Python's like, hey, I'll let you put in underscores and we'll just ignore them. The downside of that is you can put in underscores and it gets ignored. That's perfectly legal Python code. It's also perfectly ugly Python code. Right? Let's not do ugly things. But it is permissible. So you might want to tell them what the range is. I don't want to have to modify all the prompts here and all that sort of stuff, but we could, tell them that's too low or too high, or between 10 and 1,000,000 or something like that. We could go at those things, but we can validate numeric ranges as well with saying you are invalid, too low, or too high. Right? Either one of those is invalid. So the way that we do our validation loops is just slightly different, right? With our strings, it's you're not in the list of strings. I don't have a list of valid numeric values, but I know this range is invalid over here, and this range over here is also invalid, right? Or you could just say, like when we're entering some input up here, if we ask the number, negatives are invalid. It doesn't need to have both ends, right? You do that. So an int of an input, enter a number to count down from, right? And then we can add a loop here. We can say while number is less than 1, do it again. Maybe we'll like print and tell them, hey, this is invalid entry. try again. Right? And lots of different ways to modify these prompts here. But we know that less than 1 is invalid. Right? You can't count down from 0 because we're counting down to 0. And if you're negative, well, our loop will just doesn't run at all, and we're pretty sad. Okay. And a lot of times, if you're not careful here, people will say, instead of it being greater than 0, we'll say, well, number's not 0. And this is where that's really bad, because if we're not 0 and we give it negative, we'll never hit 0 because we're subtracting. Right? That's why the less than range was probably safer. Right? But this works too, if we're validating that we're not getting negative. So totally up to us how we're writing the code here. Yeah, well, we haven't got to the try and accept stuff yet. So we're working off some basic things still. So if they still give me something that's not numeric, we still crash. Right? We haven't validated that yet. We'll get there. We'll figure out how to do that in, what chapter is that here? Chapter 10. We'll figure that out, how to deal with those exceptions that crash our programs. So for now, we'll just assume when we ask for a number, the user probably gives us the number, or if it crashes, that's their fault, right? There's ways to fix it. We'll get there later. All right, so we can do these cool validation loops. Okay, so loops that are just loops that are validation loops, these are super handy. And then another kind of loop here is really useful to just let the user keep doing something until they want to be done. So a lot of times we might say, like, hey, let's give me the total of something, and we'll total it up for you here. So we might have a total receipts. We're going to start off at 0, and then I'm going to ask them to enter a receipt value. So we'll get a single receipt is an int of an input. That should probably be a float, right? Because people still deal with pennies. Because I saw a penny made in 2022. I was amazed, and also a little sad. We're still like spending the time to make new pennies, materials and resources for pennies. Like, we should just round, and everyone would be happier. I'm pretty sure. Although maybe you're upset if they like charge you 2 extra cents at the grocery store, and you have to give them a nickel instead of 2 pennies. Some people might be upset. We could probably just keep that dish of pennies, or say grab a penny dish, but that's okay. So float of an input of enter a receipt value, and then we're going to keep adding that. Then my total receipts, we'll add the receipt here. Now, how do we make this run until the user wants to be done, though? We could ask them, like, we'll say like all done equals a no, and while all done does not equal a yes. Oh, does not equal, there we go, a yes. And then ask them again, all done is equal to an input. Are you all done entering receipts? Yes or no. If they say yes, the loop will stop. Now this will perfectly work here, but if you have to enter a bunch of values on the keyboard and you're like, okay, here's a $7 receipt, no. Here's a $10 receipt, no. Here's a $3 receipt, no. You're going to be a little irritated having to say no all the time, right? Can we do better? Is there a way we could combine these two prompts into one? Well, do we know anything about receipts? Like, is there a value of receipt that is probably not going to be on a receipt? What about like a $0 receipt? Are you probably ever going to have a $0 receipt in your drawer? Like, hey, I sold nothing. And stores don't give away things for free, right? I think the receipt would still have like a coupon. I don't know. I don't know how coupons work in receipts, but I imagine it's still not $0. Is that fair to assume? Like the McDonald's survey, if you filled it out, it's like a buy one get one free. It's not like, hey, you get a free thing, right? Most of the time, we don't get free things anymore. So, do you think 0 would be an invalid value for a receipt? So what we can do, we can, instead of having to prompt twice here, we can say, while my receipt does not equal 0, we'll ask them to enter a receipt value, or 0 to stop. So this is known as a sentinel value. It's a value with a specific meaning here. And it should be an invalid value as well, a special meaning. So in this case, If we enter 0, I don't mean I have a receipt for $0. It means please stop running here. So it's an easier way to let me keep on running my program here, combining those prompts so I don't have to say enter value, are you all done? 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 It's enter a value or something specifically invalid that I'm looking for to stop. So now I can just jam away on the keyboard. When I was a kid, my Scoutmaster was a CPA, and she could type on a number pad like you would not believe. She took the book of whatever it was from her client, and this was on one weekend during tax season when she still had to do work even while we were camping. She would just type nonstop. Like she would like flip pages and still be typing while she was flipping. This lady was good at what she did to total all the books, and I don't know how accounting all works. So sure, it looked impressive. I think now we have computer programs that total things for you, but maybe some places still keep their books on paper because that's easier to cook the books. Or I mean, because computer programs are expensive. I'm sure it's not suspicious to do that sort of thing. I don't know. Does paper books feel suspicious? Like if someone's keeping their accounting on paper? You can still fool software and put fake things in software, but you like just can't erase it. So okay, I don't know. That's a whole other issue. So we can just keep on typing numbers then over and over and over and over and not really interrupt their flow. It's easier for our users. So these sentinel values are fantastic for that sort of thing. These are pretty handy loops. So while loops are great because we don't need to know when the user wants to be done ahead of time. The user can tell us when they're done, either by saying yes or no, we're all done, or giving us the particular invalid value, which is great because you don't want to have to go count your receipts ahead of time and say, how many receipts do you have? Okay, let's ask you 10 times because you have 10 receipts in the drawer. Right? We don't have to do that. That's really tedious. We want to make things easy for our people because computers are good for that. Hey, Wally, yeah, you can always improve your coding skills for sure. It's practice, a lot of practice. All right, so these are while loops. That's one kind of loop. There's another kind of loop in Python that's really common, which is a for loop. So a for loop is not like a for loop in other languages. So if you've done loops in other languages, this is going to be really confusing. If you've not, this is okay. What a for loop does is it takes a collection and iterates over it one item at a time. So we'll say for like item in some list is essentially the syntax here. So for that to work though, we need some sort of collection as some list. This works with lists, this works with tuples, this works with dictionaries, this works with strings, because that's also a collection. It's a sequence type of characters here, right? So if we just say, hey, my sum list is, we'll make it a list here because that's easy, 1, 2, 3. Now, what this is going to do here, it's going to run once per item or per value in the sum list. And maybe I should rename this here, sum collection. How about that? Because that's a better term for it here. Okay. Inside the loop section here now, in the loop body, the current value is the variable item. Like this item here is just our variable name here. So this could be apple, right? Perfect. Whatever you want to call that variable here. It's each individual item in this collection, as the loop runs, will be referred to as apple, or item I think is generally easier here. So the first time the loop runs, the value of item will be 1. And then it comes back and it says, hey, do I have more items in the collection? Yes, okay. The loop will run again with 2 as the item. And it'll come back and say, do I have more items in the collection? Yeah, 3. Okay, now the value of item is now 3 when the loop runs. So I can just say, hey, I want to print item. Not a very interesting loop here, but we can run. Nope, that's the wrong run option. Run selected. There we go. And we'll get 1, 2, and 3. So the for loop takes a collection and does something once per item in that collection. And it can work for any collection type, which is awesome. So we could go back to this idea of some word here. So give me a word here, like a 5-letter word. Ghost. All right, I like it. So we could say for, I'm going to call it letter in some word here. Again, letter is just the variable name for it, right? Now, I also want a sum. We're going to start off at 0. And I can say my sum plus equals the ordinal value of the letter. When I'm done, I can print the sum, right? Or if we want to say the magic value of some word is sum, right? So for every letter in that word, the first time it runs, it'll be a G. The second time it runs, letter will be H. The next time it runs, the letter will be O. The next time it runs, the letter will be S. The next time it runs, the letter will be T. We'll just add to this sum, a running total here, the ordinal value. So we can give this a run, and we'll see ghost is 549. So if you come up with another word that totals 549, it must be related to ghost. This is how this magic works. Okay, and maybe we can even ask the user, right? Make this an input. Enter a word, get the magic value of, right? We can go through and do that. All right, so we need to enter the word to get the magic value of. How about something other than ghost? What? Magic. Oh yeah, the magic value of magic is 513. It is not related to ghost. They do not have the same sum. Magic and ghosts are not related at all, clearly. Okay. So we can use this for loop to do something for each item in a collection, whether or not that's a letter, whether or not it's an item in a list, an item in a tuple. Now with dictionaries, so if we had like this classes idea here of, what do we have for this? We had CIS 1501 and then data science 1, or no, CS1, that's right. I remember the titles of my classes. Data scientists, and then we might have, what's calculus? Math, is it 2 something? Calc 1 or Calc 2? Oh, 115. It's not even a 200 level. 115 is Calc 1. Calculus 1. Sure. What other classes do you want to add to our list here? To our dictionary. The key will be the class name and code. The associated value will be the title. What else should we add? You want any other interesting classes? It's Monday. I get it. It's okay. All right, I'll do my. I'm sorry. Stats. Okay, so stat. What's the number? 325. And what's stat 325? Into statistics. A 300 level class is an intro class. I don't know how these things work. I kind of assume like 100 levels are generally intros, 200 levels like with the next. I don't know. Sure, why not? It's the university is just going to make up whatever they want. Actually, there's an accreditation process, but that's a whole other story. Which I think, actually, we might be due for accreditation soon. I know they wanted to wait till there were like a couple of years worth of graduates from a program before they can like officially accredit it. Anyway, so if we have a dictionary here and we want to loop through, we could say for, now with a dictionary, if I say for item in classes, and we print item, just for fun, what do you think is going to print? Because I can loop through this collection here. What do you think I'm going to get as item? The keys, yeah. So we will get the unique keys out here when we run this. Right, just the keys. So if you wanted the values, right, we could get those out using the key as the key. Seems a little funny, but so we might say something like, so here is the key colon, here's the item, and then maybe, I don't know, dash. Associated value is my class's dictionary, key of the key. Right? So item is the key value, the dictionary key of a key will be the value associated with that key. Our dictionary is a little funny how we say these things. So like if it's a list, square braces mean index of. When it's a dictionary, square braces mean key of. I didn't make it up, I'm sorry. It's just, they mean different things sometimes. Okay, so if I want to get keys and values out, we can do that. Right, here's the key and here's the associated value. Here's the key and the associated value. Key and the associated value. Cool. So when you loop through, right, when for loop on dictionaries, you get keys. So you don't get values, just keys. Same with like the membership operator. Remember, you will check for the membership of a key, not a value. So loops work kind of the same way. So in looks at keys, for looks at keys. So usually when we talk to dictionaries, we're talking about keys, right? And if you want the associated value, you have to ask for it, that sort of thing. When we get to dictionaries, there's a couple other shortcuts we can use, which are really fun, but that's essentially it. Okay. So for loops are great for collections. Now, the other thing you can do with for loops is you can make a collection really easily, which is, so let's see, let's do some other numbers here. What else should we add to this sum collection here? Let's give it some different numbers. Just shout out a couple. 42, yes, definitely. 7? Give me a couple more. 23? 107? Sure. Okay, so now we got a couple values in here. So if I wanted to, I could say for value in sum collection. You print that value, right? We don't know what it is. Oh, we're basically doing that. Sorry. Yeah, we can do that right here. So if I want to get all the values out, we can get the values out. Now, an interesting thing here, if you want to modify a value here, so I want to take item and say, let's add 42 to the value here and print it out. And then when we're done, let's print sum collection. When we do a for loop, man, the screen is not large enough. We get those values added by 42, but now when I print the list, they haven't changed. So doing this for loop over a collection is essentially giving me copies of the values. So if you modify the value inside the loop, nothing happens, right, when the loop is actually done. So we've changed it for inside the loop, but when the loop is over, we don't keep that change, right? Because we have a copy of 42 that says, okay, I can add 42 to 42, and now it's 84. Okay, give me 7, or give me a copy of 7, add 42 to 7, now we get 49. Give me a copy of 23, give me a copy of 107. So we're doing arithmetic with the copies, not the original values. So if you want to modify original values in a list, you have to use index notation. We have to say the list at a given index and assign it a value. Now, we don't really have indexes here though, right? I know what the indexes should be, right? This is index 0, this is index 1, this is index 2, this is index 3, right? So if I want to do something for each index value, I could say, hey, sum collection at index 2 plus 42, and add 42 to it. I don't have to do that one at a time, right? So what we could do instead is we can say, I want for index in, well, do we have a collection that gives me the values 0, 1, 2, and 3? No, we don't, but Python has a shortcut for you. It's called range. So range will give you a collection from 0 up to, but not including the value you give it, which is actually really helpful. It's confusing because sometimes you get the value, sometimes you don't get the value. Sometimes you just have to remember it, I'm sorry. But how far do we want to range? We want to range up to 4, right? So if I print index here, if I just get the index for range 4, I'm going to get 0, 1, 2, and 3. Right, so range gives a collection from 0 up to, but not including the number. So I'll get 0, 1, 2, and 3. Now that works out really nice because those are the indexes I need. But what if I don't know that there are exactly 4 in here every time? What if this was some sort of loop that I said, hey, enter a number until you're bored. Enter a number until you're bored. Enter a number until you're bored to build out some sort of list here. Right? So if we didn't know how many were in it, do we have a way of finding out how many values are in a list? Yeah, the length. So we could say in range of the length of some collection. So you'll be doing this lots here, ranging over the length of something, because this will give you each individual index. And if you have the index value, now I can print some collection at the index here. Now again, this won't be very interesting because we haven't changed anything yet. So I'll get out all the values that we put in, right? We get the originals, but now if I want to modify them, I have the index. Now I can modify them. So in here then, I can take my sum collection at the index and add 42, and now go. Yeah, there's other cool things we can do with range. Wally, we'll get to in a little bit. We want to start with the slow one. So ranging through the indexes, modifying the array or the list by index, these will stick. So now if I print some collection when it's done, we'll have actually added 42 to the values inside the list because we're not working with copies, right? We have a copy of 0 and a copy of 1. We don't care about the indexes. We're not changing the indexes. We're changing the value at that index in my list here. Right, so now I get the modified version of the list. Right, we've actually modified what's inside the list there. So this is how you would change values in a list by index. Does that make sense? Like comparing it to, you get copies here, just to show the differences there when we're looping through things. So ranging over the length of something is really common if we want to modify it. If we don't want to modify it, sure, just go for it with a for loop, but you can't modify it. Right? So it depends what we want to do. So if I were to ask the user, like, hey, give me the value of all the items you bought, and then I'm going to go add the sales tax for you, we probably want to go modify those values. So if I just, hey, just give me a list, I'm going to total it for you, we don't care. Right? They can enter all the values, we can total it up, no big deal here. We can go through those collections. Awesome. You folks are doing great here. Let's see how far we're getting. Nope, that's the wrong link. This one here. Loops, 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 loops. Why is that up there? I'll have to fix that. For loops, range. Yep. So for loops are great for going over collections, or if we just know how many times we want to ask the user for something. If I want to ask you to do something 5 times, right? We could say, hey, count here is 5, and while count is not 0 or something like that, do something, and then we could take count -1. Or start count at 1 and count up to 5, or anything. Like, you don't have to go down. You can also count up, or any sort of arithmetic you want here. This is fine, but this was 3 lines of typing to get you to do something 5 times, right? And I'm lazy. I don't want to do something. I don't want us to type 3 lines of code. So I could say for, I don't know, this is what, count in range 5. Now I don't actually need to use the count variable anywhere inside the loop. I can totally ignore it if I want. Right? I can just say print, hey, please do ABC, or enter yada yada yada, right? And whatever we want to have happen, we could just put inside the loop here. Like, hey, can you buy something 5 times? Hey, light bulb moments are going off in your heads, right? Right? I don't need to use the word count, or like for your purchase number if you wanted to count, sure. Purchase number 1, purchase number 2, it's gonna be fancy. Or we can just ignore it, it will just happen 5 times. 1 line of code versus 3 lines of code. And then if you're doing a for loop, you basically can't have an infinite loop. There are ways you can do it, but we don't know how, and that's okay. So essentially, for what we care about now, loops can never, pretty much, ever be infinite, right? Where with the while loop, if I did the wrong thing, if I added one instead of subtracting one, or if my condition was backwards, if I said if it's greater than 0 versus less than 0, or things happen all the time, right? It's possible to make your while loops infinite. Basically not with for loops. So not only is it less typing, but it's like safer, right? So it's handy. We like them for doing something a specific amount of times, versus the while loops are great for like open-ended things, or like, hey, tell me something until you want to be all done. We can't do that with the for loop, right? I can't say enter values until you're done with the for loop, because there's no collection to iterate over here at that point. The next fun thing we can do with loops is you can put loops inside of loops. Now we've done that already, actually, with our guessing game, right? Where we had a while loop inside of another while loop. Sure, that's fun, but it's not, we're going to do a different thing with a loop inside of a loop. We're going to use for loops. So if I were to say, I wanted to know all the possible times my clock could show, all the different hours, all the different minutes, all the different seconds. We can do that with a loop inside of a loop inside of a loop. It gets a little crazy here, but we can do that. We can say for hour in range 24. Now we're going to use 24-hour clocks, military time, because it just makes so much more sense. AM and PM is stupid. And then we'll say for minute in range 60. And then we'll say for second in range 60. A loop inside of a loop inside of a loop. We're going to print a little formatted string here of hour colon minute colon second. And if you remember back to this formatted string here, you could do other cool things with your syntax, right? Does that ring any bells? Like we did some rounding, I think, with one of them, with like the 0.2f or something. So we want, and I can never remember how to do this. So this is Python format string integer padding or something like that. Format string. Don't want 0.2f though. All right, that was not the hit I want. Format string integer minimum digits is, I think, what I want here. Yes, okay. So colon some number of digits. Sure. We'll be able to format it for me. So if I want 5 digits here, I don't want 5, I want 2, because I want 00 or 01 or 02, right, for your minutes, hours, and seconds. Otherwise it looks really funny here. So we'll put colon 0 to D, I think, for all of these. D for digit, because I for integer would make too much sense. I don't know. This is why I have to Google this stuff. It's not worth remembering here. But if we want to loop inside of a loop inside of a loop, what's going to happen is hour will be 0, right? Because we start at 0, we go up to, but not including 24. While hour is 0, we'll start the minute loop. All right, minute starts at 0. While minute is 0, we'll start the second loop. All right, the second loop is going to run from 0 to 59 while hour and minute are still 0. When this loop is done, we've done all 60 seconds, this loop will stop running, and then we'll go back up to this loop here and say, okay, we did 0, give me the next minute. Now minute will be 1. Hour still hasn't changed yet. So for hour to change, minute has to go from 0 to 60. And then the hour will change. Right? So the entire inner loop runs from beginning to end for this to happen one time. So when we run this one, we should get all the possible times on a 24-hour clock, which was super interesting. I mean, it's just an example here, right? Not very useful for anything. But maybe if you wanted to ask the user to enter a time, we could like add all of these into a collection and see if that's valid that way. It's probably not a very useful way to validate time, but you could, right? Or you could just say, hey, is the hour in a valid range? Is the minute in a valid range? Is the second in a valid range? We could do something like that. There's lots of different time. Working with time is really obnoxious. Time and dates is really hard to do in code, unfortunately. It's just a hard problem. But we've put a loop inside of a loop inside of a loop, right? That was fun. Other fun things you can do with loops inside of loops inside of loops, and we're going to practice some of these in lab here, is you can draw shapes with characters, which is affectionately known as Ascii art. And I'm scared to Google it sometimes. But so remember, ASCII, or the Unicode, is the idea of how I assign numeric values to characters. So people long ago figured out, look at this, ASCIIart.eu. Let's look at animals. There's 6 different aardvarks done with characters. So people can draw art just using characters. This was very common before we had actual graphics on computers. And just, it's nostalgic and cute for fun too. So you can draw things using just characters here with given formats. Now, I can't make an aardvark unless I copy paste it. I'm not that talented. But I can make a rectangle, because rectangles are pretty easy. Exactly, a rectangle is basically an aardvark. You just use your imagination. Thank you, I appreciate it. I'm basically an artist. You know, just sure. So let's ask the user, because that's more fun here. So we'll get a length here. It's an int of an input of how long of a rectangle do you want, and then we'll get a width here of an int of an input. And I'm lazy, I'm going to copy paste. How wide of a rectangle do you want? And really, this is probably tall, because right, you've got like height and width, or length. I don't know. Length. Someone told me once length is supposed to be longer than width. Okay, I'm not really good at geometry, so that's okay. So if I know this is height, then right, height and length. If I need to do some length for every height, right, I can say, okay, for this is row in range of height. So if you want a height of 10, this will give me 10 times something. Something will happen 10 times, right? Then what I can do for the length here, we can say for this is, I don't know what, character in range of the length here. I can print. I'm going to use the star, because I think star is a fun character here. And then I think you've seen in Zybooks, I've never done it because I don't usually need to, you can change the ending character so that it doesn't give you a new line. Have you seen that? Thought you did it in one of the Zylabs, maybe. Yeah, okay, thank you. So we'll just say end with nothing here. Changing the ending character so that I doesn't go down a line, right? Doesn't go down a line. That's probably spelled right. Now, after I've printed every character in the length here, so I've done whatever your length is, that many stars, now I want to go down a line, right? So when this loop is done, now I just want to print, which is a new line. And I'm not printing any text here, but it will give me the new line character. So every row will get the length number of stars printed, and then a new line. And I'll go to the next row. Print that many stars, go to the next row. Print that many stars, go to the next row. So if we run this here, I'm going to put a breakpoint in. Can I debug? I think I can. So how long should a rectangle be? 6. All right. And how tall should a rectangle be? That's a square. Sure. Oh, I didn't debug. Sorry, I'll have to run it in debug mode. We'll see. Oops, where'd it go? I zoomed in way too much. Go down. 6 rows of 6 stars each. We've now printed a rectangle. It's not perfect here because the width is, you know, but just pretend it's art, right? It doesn't have to be perfect. Yeah, definitely. Abstract art. So we can print out cool shapes based on what the user wants. Sure. So a loop inside of a loop then. Now, Python actually gives us a shortcut. We don't necessarily have to do this, but this will be useful for printing the other shapes that we do need to print. Maybe not even. So the easier way in Python, remember, because you can do silly things in Python, like take the star character. We want to print the star character. Oh my goodness, the star character times the length. You can multiply strings here, and then we don't need this other print here. Like, this is the easier way. You don't even need a loop inside, because taking a character times a numeric value repeats that character so many times. Here, the loop inside of a loop, I think, is a better illustration of what we're trying to practice here, but we can do that. Right, so let's run these ones. So how long of a rectangle should we do? 7. And how tall of a rectangle should we do? 4. So we have 7 rows. Oh, I'm sorry. This is repeated twice is why. So we actually have, this is 1. Oh, sorry. The first 4 was the first loop, and then the second 4 was the second loop. Right. We should just print out some empty space here. So this is printing or the easy way. Here. There we go. So then we print that between these two. So 4 rows by 7. We printed out a rectangle. And so we can do some fun things. So we'll practice loops. We're going to do some other shapes in lab that are more fun. It's all about the arithmetic. But practicing the loop and going through that process is fun. And then we'll work a little bit more with some dictionaries for fun with loops for some practice. Now, for your project, you don't need to do loops. If you want to do loops, go for it, right? But if it's already done, you don't have to change it at all. If you want to save yourself some typing, you can use a loop. Okay. Most of the time, it won't work out that way that you'll get shortcuts later on. But there's only so much you can do like without a loop. If I just said buy one item, that's not very interesting at all, right? So, apologies for making you write it out the long way, but loops will save you some time if you want, but don't feel like you have to go change it, right? There's no points there for the loops. Right? Questions, thoughts, concerns? I did get a couple questions about the most expensive item, and I realized I worded it really badly here. So I had said most expensive items they bought per order total, and I guess that's not very helpful, because what I had in my head is that that's the item price times the quantity, and that's what I meant by items and order total. I get if you didn't understand that, because that sounds really awful now that I'm reading it again. So if your most expensive item is just by item price, perfectly fine. I'm not going to mark you down for it here, and don't need to go change anything. But if you haven't done it yet, it should be item price times quantity is the most expensive line item purchase. Right? So if I buy 100 bananas, it probably costs more than buying a pineapple, even though a pineapple costs more than a banana. Right? So yeah.
Just to clarify, did you just want to print out the highest amount? So if it was the pineapple at 105 by 500, or you want to program it by the pineapple first?
The more details is better. It doesn't specify, right? It just says what was cheapest and most expensive.
Because in that case, you just use the max.
Yeah, you could do that for sure. Yeah, more details is better. But again, I wrote this rubric myself, and I'll stick to it. This is how I'll grade you, because it doesn't say, please tell me the name and quantity and total price of the most expensive items you bought. It just says, tell me the cheapest and most expensive. That's my fault for not giving better details. So any way you want to interpret that is fine. I'm not going to be too particular. Is that fair? Okay, cool. Again, so on Wednesday, first thing we'll do is go over how I might solve Project Zero. I'll use loops if that's okay, because I'm lazy. Is that fair? Again, not expecting you to. You don't have to. You're welcome to if you want, that sort of thing. And then someone else had asked, I specified if you don't have enough money and you don't have the right quantity, but I never said, what if they want to buy something we don't sell? Well, okay, we could add checking for it. If you want to add checking, that's probably the right thing to do, but if not, that's okay. It can just crash, because we don't have that item in the dictionary. That's on the user for typing in something bad. It wasn't specified. Okay, so again, I'm going to do my best. That's why I try and put these rubrics in. So I will literally score them based on the rubric. So if it doesn't specify, I'm not going to hold you to it. Best I can try, because I want to be fair about that. Because they're nonsense projects, because we just make them up on the spot. But okay, all right, awesome. So we'll go meet up in lab in just a little bit and practice some loops. Thanks, folks. Thanks for hanging out online.